Hi everyone, we are Group 1 Synergy Group, and today we are excited to walk you through our vessel construction project for INDE6332. This project challenged us to think like real engineers, like starting with selecting the best vessel design, then planning out every step to its construction. From choosing materials and estimating costs to assigning roles and building a timeline, we had to apply both technical knowledge and teamwork. We'll be sharing how we approached each part of the process and what we have learned along the way. I'm Priyanka Arhi, the project management for this assignment, and we are a group of 8 people. My teammates are Sai Kailash, Tyler, Venkatswamy, Arafat, Ibrahim, and Victor. And now Tyler will tell you how we have started this project and selection matrix.
So the first section of this project focused on developing a structured process to evaluate and select the most appropriate research vessel in response to an RFP from the Texas Parks and Wildlife Department. As a group, we worked together to build a structured evaluation matrix to compare all 24 potential vessel configurations. These varied in size, hull material, engine type, and cabin layout. While each of us brought individual input and perspective, the matrix reflects a collaborative effort supported by team research and shared decision making. We identified four key evaluation factors: construction cost, operating cost, speed, and ability to handle work conditions. These were chosen because they cover the most critical aspects of performance and feasibility. Each factor was assigned a constraint, for example, minimum required speed, and a weighting based on how important we believed it to be. The matrix ensures that vessels not meeting the baseline requirements are penalized, and those performing better in more important areas are scored higher. To make this model usable without access to real industry pricing, we applied some scaling multipliers to the base costs and performance values rather than entering raw numbers. For example, a twin-engine aluminum vessel would have a higher construction and operating cost multipliers than a single-engine fiberglass vessel. This allowed us to estimate and compare each configuration without needing exact prices, just logic and relative scaling. The bottom row of this section shows the final constraints we used to score each vessel. These include our assumed maximum construction and operating costs, minimum required speed of 20 knots, and a minimum acceptable work condition score. These thresholds were based on market research and what seemed to be reasonable given the use case. Each configuration was then scored from 1 to 10 based on its performance in each factor using a normalization method. Those scores were combined among the weights we set, and vessels that failed a constraint received a 0 multiplier for that category. In the end, this approach gave us a clean, logical way to rank all 24 options. The highest scoring configuration ended up being a 30-foot fiberglass vessel with a single diesel engine and a 3/4 cabin. This offered the best overall balance of cost, performance, and feasibility.
Hello everyone, I'll be just giving a brief summary of what we did for assignment 2. Um, so our team, I was the project manager for this assignment, and we developed a two-phase organizational strategy for a startup vessel production company. In the initial phase, we adopted a pure project-based structure, ideal for startups. This ensured clear accountability, fast decision-making, and direct communication, which are essential when delivering a specialized product under tight deadlines. As the company expands, we transition into a matrix organizational structure designed to handle the complexity of mass production. In this model, employees report to both a functional manager and a project manager. This dual authority system enhanced collaboration across different departments, such as design, manufacturing, and quality assurance, while maintaining alignment with company-wide project goals. The matrix structure encourages specialization without creating silos, allowing us to allocate resources more flexibly and drive innovation. It also supports scalability, giving us the ability to manage multiple vessel production lines while optimizing cost, quality, and delivery schedules.
So for homework three, which is the bill of materials, the way we went about it was to classify into nine major systems categories, and which ranges from the all construction materials, the propulsion system, the navigation, the electrical, the anchoring, the sanitation, the research, the freshwater systems, and the lastly, miscellaneous, which was classified as other halls and hens. Um, at the end of the day, the total estimate for bill of materials was $174,055. So, and the way we went about the bill of materials or the research was to divide each of these major systems among each others based on our strengths, and we were to research on the most appropriate materials for the project. And we developed or resource these knowledge using West Marine website, the Depender website, and also the eBay website. We also use some other websites for some other ones, but those are the main ones we use in achieving the bill of materials. And as you can see on the PowerPoint, the earth construction materials was the most. He also estimated the total hull and deck weight to be 10,000 pounds, which is 50% of the total weight of the vessel. And we estimated the total weight of the vessel to be 20,000 pounds. And as you can see on the PowerPoint, the materials that we use, which is the fiberglass fabric, to the release agents and the proportion of the weight by mass that we use in estimating.
So next, to begin planning the vessel construction project, we created a detailed work breakdown structure. So this allowed us to divide the overall project into manageable tasks and then assign resources more effectively. So here each task is again divided into subtasks. So it served as a foundation for budgeting, scheduling, and task ownership. So the WPS also helped identify the scope clearly and ensured each phase was systematically handled. So next we developed a linear responsibility chart which clarified who was responsible for what task within the team. It ensured accountability and smooth communication throughout the project. Each task from the WPS was assigned to team members and overlaps were minimized by clearly defining responsibilities. And using this information from WPS and LRC, we created a Gantt chart that mapped our project across like 20 weeks. It helped us visualize dependencies, track progress, and allocate resources effectively. So the chart also enabled us to identify overlapping tasks and ensure the project stayed on schedule by flagging potential delays.
Hi everyone, my name is Arafat Oladipo. I was the project manager for Homework 5, where we defined the project budget. For the project budget, we defined this using the work breakdown structure from the previous assignment. So using this, each component owner, so we had pre-divided the components or the systems into individuals within our team. So each system owner, like the vessel sanitation navigation system, defined the number of man hours and the number of professional, skilled, and unskilled labor that was assigned to each task. And this was how we got the total man hours and the total number of professionals for each task we had listed in our work breakdown structure. Like the work breakdown structure, we also used the Gantt chart from the previous assignment. This, along with the definition of number of professional, unskilled, and skilled tasks in the previous slide, we were able to divide our project labor resources needed into months. We had professionals at $100 per hour, skilled labor at $40 per hour, unskilled labor at $40 per hour, and then for each month we had a fringe of 25%. This came to a total of $243,866. As well as a monthly labor cost, we also had the monthly materials cost using our bill of materials from the previous assignments. As you can see, our bill of materials were mostly used between weeks 4 and 8, essentially month 2. Thank you. For the total budget, we just combined our labor cost, supplies, and then we added an indirect cost of 30% across each month. And then that came up to a grand total of 543,296.
Hey everyone, I'm Saikalash Kandla, the project manager for Homework 6. Here we developed the project network diagram for our visual configurations. Here you can see on the screen, this is the master sheet for the project network diagram. And there are 32 activities in this network diagram, which we basically refined from the work breakdown structure table. And also we took the inputs of the optimistic time from the work breakdown structure table. And also we calculated the expected time and the variances from optimistic time and pessimistic time. And also we finally created the network diagram with the 165-day timeline, which basically 33 weeks for the project. So, and also we jot down the early start, late start, slack time, and the finish time from the network diagram. As you see on the screen, this is the network diagram for our project. So we developed this network diagram using Project 365 software, uh, such that which basically shows a better understanding on the flow of activities of the project. And also on the top of this network diagram, we can see there are some activities in the red color, which are the critical path or critical activities for our project. So basically where we cannot add any slack time or slack duration for these activities. And also when dealing the project manager need to take care of these activities by proper maintaining these activities such that such that we can prevent any potential delays or address the system challenges such that we can successfully complete our project.
Hello everyone. I'm Venkateswamy. This slide is critical path analysis. The critical path method is a project management technique used to determine the sequence of dependent tasks that directly impact the overall project duration. And the applications for the Vessel project are identified 8 critical tasks that define the shortest time in which the project can be completed. These tasks had zero slack, which means that any delay would extend the total project duration. The why it matters is this critical path method ensures focused resource allocation to high impact tasks. It helps manage project risk by highlighting time sensitive activities and essential for developing realistic and optimized project timelines. By using CPM enabled the team to construct a 165-day master schedule, ensuring on-time deployment and operational readiness. This slide represents the theoretical perspective of project network diagram. A network diagram is a graphical representation of project's activities and their interdependence. It visually maps out the workflow and shows a task sequencing. The role of project network diagram in the project is it includes 32 interconnected activities covering phases from material selection to final deployment. It enables identification of dependencies, parallel tasks, and critical milestones. And the project manager management value was it improves the visibility of project structure, facilitated communication among the team members, and it is supported effective tracking of progress and bottlenecks. This network diagram served as a central planning tool and aligning team efforts and enhancing the decision making throughout the vessel life cycle. This crash chart represents the theoretical perspective of schedule crashing. Generally, crashing is a technique to shorten the project duration by increasing the resources or cost to accelerate the critical path activities. Um, in this project implementation, a 250% of crash rate was applied, and additional cost of 66,327 dollars was spent, which resulting in 21-day time savings. And when we need to crash is when the time is more than the cost, and to meet the deadlines or regulatory requirements, we'll go for the crashing. And the risks, increased budget, and the risk and rewards associated with the project crashing are, it increases the budget but provides schedule flexibility, and it requires careful evaluation of trade-offs between time and cost. And the outcome of this project crashing is it was effectively applied to critical tasks to maintain project momentum and ensure delivery within the preferred timeline. Uh, this slide represents the network diagram and the results obtained through crashing. And also this represents the resource leveling operations. Generally, resource leveling is a process of resolving resource conflicts by adjusting the project schedule to better distribute the workload. It was used to avoid over allocation of labor, especially during procurement and construction phases. And also, it addresses peak in manpower needs by staggering hiring and task assignments. The key events in resource leveling are hiring and firing adjustments across multiple phases, and minimized idle time and overstaffing. Uh, the benefits of the benefits of the resource leveling is it saved $6,150 in project cost. It created a more sustainable and realistic labor schedule. And by the conclusion, resource leveling supported a more balanced project execution, allowing the team to manage resources effectively without compromising the deadlines.
Hi everyone, for the project leveling assignment 8, we took our refined budget from assignment 7, our network diagram from assignment 6, and from assignment 5, where we defined the project budget, we took the tables where we had defined the number of professional, skilled, and unskilled labor slash worker assigned to each task. So here we have plotted the labor versus days, and we found that we had 15 hiring events and 15 firing events. To level the task, we moved around certain activities around their slack to ensure that we had reduced firing events. So after moving around certain tasks around their slack, we had a slight increase in hiring events from 15 to 16. However, we did decrease the firing event by 1/3. Um, ensuring that our total saving came to 6,150. Um, the slight increase in hiring events we had was just so we had a more balanced work field and ensured that we were retaining staff better. In the process of leveling the tasks, there were certain tasks where we did level them, however, we used all available slack, essentially making them added to the critical path. There were also other tasks that, due to the predecessor successor relationship with other tasks, became added to the critical path. These were just three trade-offs that needed to happen for us to have a more efficient system. In addition, 11 tasks listed on the right on the bottom here were added to the critical path. Thank you.
So, this slide highlights everything we were able to accomplish through this project. First, it gave us a real sense of what it's like to plan a visual build from the scratch, just like we might do in industry. We didn't just focus on theory. We used real project management tools like WBS, responsibility chart, Gantt chart, and network diagram to stay on top of every task and deadline. Our total estimated budget came to around like $174,000, and we based that on actual materials from suppliers like West Marine and eBay. So our numbers were as realistic as possible. So we also created a full 165-day schedule and used critical path analysis to identify the 8 tasks that had the biggest major impact on our project timeline. And by leveling and crashing the schedule strategically, we managed to cut costs by over like $6,000 without affecting the quality. So more than anything, this project helped us strengthen skills that go beyond the classroom, like teamwork, time management, budgeting, and making real-time decisions. So all of which will definitely help us in our future careers. Thank you.